share my screen with everybody at home. All right, there we go. So here are those two function values. G of x equals negative x squared plus 1, and h of x equals negative x plus 2 squared minus 3. And on there is the parent function. I went ahead and drew that in. So those little dotted parabolas are the parent function. So if we recall, so I'm going to skip over where they draw these two, because that's what we just did. All right, so what that's going to bring us to is doing that shifting by looking at the parent function is we have to use the process of what is called completing the square. Okay, which I have worked through one right here on the side. If you can see that, I'm going to try to get this a little bit closer. All right, so we are starting now. I'm going to a separate problem. Here's just a quadratic in our general form. And you've done completing the square in your, I'm sure in your integrated 3 class. So what I'm going to do is just going to sort of review it. All right. So what we're trying to do is we're trying to get a perfect square trinomial, so that a perfect square trinomial, when you factor it, it factors to a binomial squared, which if you go to that general form, it is a and then x minus h squared, which that is a squared binomial. So remember how we do it. What we do is we take the first 2 values of the quadratic, and the first thing is you've got to have an understood 1 in front of the x squared, which this one already does. All right. Then, well, what I'm going to do is I'm going to put in parentheses. I'm just going to look at the first 2. And then what we do is we take the b term, or that middle term, and we take half of it. And then we square it. All right, because what we're doing is we are looking at these first 2 values, and we need to know what number can I add or subtract to those 2 that would give me a perfect square trinomial. And you take half of that b value and then you square it. So half of -6 is -3. -3 squared is 9. Then if you remember, what we do is right here is we add that value to those 2. Now, what we have to be careful of, though, is I can't just randomly add a value of 9 to a function without changing the function value. So what we do is we add the number and then we subtract it. 9 minus 9 would be 0, and I really haven't added anything of value. I've just changed the way it looks. Okay? Then what we do is I take that -9 and I'm going to move it to the outside of the parentheses there. All right. And then the reason I did that is because now this right here can be factored as a perfect, or as a binomial squared. And the binomial is just x, and then you either take half of the middle number, or you can take, you take half the middle number, because that'll tell you if it's plus or minus. This is always going to be a plus here. So half of -6 is -3. So that's x minus 3 squared, right? If I multiplied it back out, that would be x squared minus 3x plus 9, and that's where we get the +6. And then what I do out here is I go ahead and combine that, and then that is -4. Now, if you'll notice, this is now in my form of a x minus h squared minus k. So this now, so when I do that, it puts it in my standard quadratic form. Okay, so I would know that this parabola, if this is a parabola, its vertex is at the opposite of the h value. So this would be a parabola that's vertex is at 3, -4, and it opens up because there's no number out front, so that's a +1. Okay, so now let's go back to the problem that they gave us. Let me try to see if I can zoom in on that a little bit more. All right, so here's the problem that they gave us. Now, the problem with this one, all right, so they're wanting us to find the vertex of this parabola and basically put it in standard form. All right. Well, before I can complete the square, I've got to have an understood 1 in front of the x value. So what I do is I'm going to put in parentheses the a squared or the x squared in the x term, and then I'm going to factor out whatever number's in front of the x squared. If it's negative, I would factor out a negative. If it's positive, I'd factor out a positive. That's a positive 2. And I'm only going to factor it out of these two, which would leave me x squared plus 4x, and then I still have this plus 7 out here tagging along. Now, to complete the square, I take half of 4, which is 2, and then I square it. So 2 squared is 4. And then I have to also subtract that 4 so that I'm not changing the value of this function. All right. Now, I want to take and move this negative 4 out, but I cannot just move a negative 4 out because of this 2 that's out front. Remember, right? This 2 is actually multiplied by everything that's on the inside. So what I have to actually do is whatever's out here, I have to multiply it by that negative 4 before I move it out. So this is going to be 2x squared plus 4x plus 4, and then 2 times negative 4 is negative 8, and that's what I'm going to move to the outside. Because essentially, I added 8, and now I've subtracted 8. All right, now I just want to clean it up a little bit. So this is going to be 2, and then it's going to be x, and then half of that middle number, plus 2. And then 7 minus 8 is negative 1. So now this is in standard form. I know now what is the vertex. The vertex is the opposite of h, so that's negative 2, k right there. And I look out here at this a value, that is a positive 2, so this opens up. So that's basically what they're wanting you to do there, is tell us the vertex and tell us how it opens up or down. All right? But they do want you to be able to get it into vertex form or standard form. All right? Now let's look at one more of these. Negative x squared minus 4x plus 1. All right? Same thing is I've got to have this right here, but I cannot have a negative x squared. I've got to have a positive x squared. So what I'm going to do is I'm going to factor out a negative, which would make that positive x squared plus 4x, and then plus 1. And that's negative x squared plus 4x. Half of 4, once again, is 2. 2 squared is 4. So I'm going to add 4, subtract 4. And then I've got a negative x squared plus 4x plus 4. I'm going to move the minus 4 out, but I've got to make sure I multiply it by this number on the outside. That's like a negative 1. So negative 1 times negative 4 is positive 4. So I got plus 1 plus 4. And then what do we have? A negative x plus 2 squared plus 5. So what's my vertex? Negative 2 comma 5. And because this is negative out front, this one opens downwards. All right. Now I do want to show you this one also. This one we don't really have to complete the square because it does not have an x value. I'm just going to rewrite it as negative 1/2 x squared plus 16. So this is just like if I wanted to put it in standard form, it would be x plus 0 squared plus 16. Okay, which now the vertex is at 0, 16. Remember, 0 is neither positive nor negative. And then because that's a negative 1/2 out front, that opens down. All right, so that's how we're going to go about getting things into standard form. All right, and this is just going back over exactly what we just did. And then they use the graphing utility there. All right, let me show you. There's a couple other things that I need to show you here before we go on with that PowerPoint, because the PowerPoint does not add it on there. That's going to be problems on your. All right, another thing they're going to ask you to do is this right here. Is the light on? Is they're going to ask you to write an equation. This is straight from a couple problems on your assignment. They're going to ask you to write an equation in this form of our vertex form or our standard form equals a x minus h squared plus k. All right. And they're going to give you the vertex, and they're going to tell you a point that is passing through. So now the first part of it, filling in the h and the k, is easy. Here's h and here's k, right? So this is going to be f of x equals, we don't know what a is yet. That's what this point up here is going to help us do. But we can say that it is x minus 3 squared minus 6. Okay? So I've got almost all the equation written of the parabola that has a vertex of, oh, I'm sorry. I did it backwards. This is the h and the k up here. This is the vertex. So let's scratch that. It's going to be a x minus 1 squared plus 2. The vertex is the h and the k. All right. Now, what we're going to do to find the value of a is, because we have given the point 3, negative 6, all right, to find the value of a that goes through this point right here, is 3 is the x value, negative 6 is the f of x value. So what I can do is, the input is 3, so if I put 3 in for x, I know that that's going to output negative 6. So what I can do is fill in those, the x and the f of x, and then now I can solve for a. So if you'll notice, this will be negative 6 equals a, and that's going to be, what, 3 minus 1 is 2, 2 squared is 4, plus 2, subtract 2, and I get negative 8 equals essentially 4a, divide by 4, and I get a equals negative 2. So here's the a value, here's my h and my k, and so what I can say is the formula for the equation that goes through or has a vertex of 1, 2, and passes through 3, negative 6, the a value is negative 2, so that's going to be negative 2 x minus 1 squared plus 2. All right. And there's going to be a couple problems like that on your assignment, and I'm going to go through one more there. Any questions? All right. Same thing here. All right. So as vertex of negative 5, negative 1. So what I can gather from the vertex is I know it is a x minus h, so that's going to be x plus 5 squared minus 1. Now to find the a value, I'm going to use the point that it's passing through. The input is negative 3. So that's going to be negative 3 plus 5 squared minus 1, and the output is 4. And so we're just going to solve that for A. So that's going to be 2 squared minus 1. So that's going to be 4 equals 4A minus 1. So I add 1, and I get 5 equals 4A. Divide by 4, and A equals 5/4. So now I have my A value that I could fill in right here. So my final f of x equals 5/4 x plus 5 squared minus 1. All right. All right. And I'm sure. Let me double check the assignment and see if there's anything else. Sketch the graph. Sketch the graph.
Is it in a break?
Yeah, if y'all need to take a bathroom break, go ahead. People at home, we're on our bathroom break, so y'all just hold on for a moment. Get back to this and try to finish this up here. All right, going to talk about finding minimums and maximums. All right, now, obviously, one way you can find the minimum or maximum is you can put it in standard form and find the vertex. The minimum or maximum of a parabola is the vertex. If it's a negative A, it opens down, that's the maximum. If it is a positive value A, it opens up, and that's a minimum. Okay? They are going to introduce you to one other way. Actually, they're going to introduce you to a way you can find the vertex based off the general form of ax squared plus bx plus c. And this is a little bit tough to understand with the way they have written it, but what you basically need to know is the x coordinate of the vertex is found by taking negative b over 2a. So the b value is the term in front of the x. If it's a minus, you got to make sure that's a negative b, and then the a value. So to find the x coordinate of the vertex, if you're not in vertex or standard form, okay, you're in general form, you can take the opposite of whatever b is, or negative b. All right. So if b is positive, it's going to be negative number there. If b is negative here, it's going to be positive when it's over here, over 2 times a. Then to find the y coordinate, what you do is you take that value and you substitute it into the equation for x and solve it for f of whatever. That's what this stuff means right down here. That's why they're getting the x coordinate is negative b over 2a, and the y coordinate is f of that, which means this is that x value you're substituting in. All right. So I don't think we need to do that, and I don't want to do that. I want to pull up another problem. So let's say we have f of x equals x squared minus 6x plus 5. Now, one thing I could do is complete the square like we did earlier and find the vertex this way, or I can say that the x value of the vertex is going to be negative b over 2a, which b is negative 6. So the negative of negative 6 over 2 times the a value is 1. So that is going to be 6 over 2, which is 3. So the vertex this thing's hard to write with, is going to be 3 comma. Now to find the y coordinate, I'm going to take, and I just find f of 3. And so that would be 3 squared minus 6 times 3 plus 5. And you could just push that in the calculator, but that's going to be 9 minus 18 plus 5, which is negative 9 plus 5 is negative 4. So that vertex is negative 4. Now, how do I know if that's a minimum or a maximum? Well, the a value is positive, which means this is a parabola that opens up, which means that is a minimum. So this is a minimum value. All right. And that's all we're going to do on that. I don't think there's not one like that on there. There's one more problem I want us to work through because there is one like this on the assignment. And I need to show you how to use your calculator here. So a baseball is hit at a point 3 feet above the ground. What is this? This isn't what I want. Let's scratch that. Let's go to what I want is this right here. All right, we're going to be talking about a football punt. Okay. This is the actual problem we're talking about right here. So we're talking about a punt that forms a parabola. All right. And I'm going to write the equation down that they have in the book. So the equation they have is y equals negative 16 over 2025 x squared plus 9/5 x plus 3/2. There's going to be a problem just like this on your assignment. And it wants us to find, they want us to look at the graph of it. They want us to find how high is the ball when punted. They want to know how high does the ball go? And D, where does it hit ground? All right. So if we were looking at the graph of the punt, they want to know this value, they want to know this maximum, and they want to know this value. All right. And we're going to do this on a calculator. So I want to show you the way we get this information on a calculator and be able to look at the graph. All right. Let's see. Windows 6. Oh, Zoom 6. All right. So I'm going to type in that equation. That is going to be negative 16 over 2025 x squared plus 9 fifths x plus 3 halves. All right, now here's the problem. You look at the graph initially, and it looks like a line there because it's so far zoomed in. So what we got to do is we got to think about a football field. And football field is in yards, 100 yards, 300 feet. So I'm going to look at about 250 foot here. And I'm saying they can't kick it any higher than 150 feet. So what I'm going to do is I'm going to change my window. And I don't care about the negatives. There's nothing that happens over here, and there's nothing that happens down there. So I'm going to say it goes from 0 to 250 on the X and 0 to 150 on the Y. And then let's see if that punt fits in my screen. All right, so you do notice that it fits in the screen. All right, so we'll be able to pick our graph up out off of that. So that's what the graph looks like. The second thing is, how high was the ball when punted? Well, it was punted right here. This is time versus height of the football. All right, so when he punts it, it's at time 0. So I could either substitute 0. I could substitute 0 in. Notice if I substitute 0 in for x squared and x, that's going to be 0 plus 0 plus 3 halves. So the ball when punted was at 3 halves of a foot. All right. You can also hit on your calculator, hit second table, and look at the x. When x is 0, it tells you right there that the height was 3 halves. All right. Now, the next thing we want to know is how high was the football? What was the highest the football was? We need this maximum. Well, we could algebraically do it, but remember, when we hit second trace, we can find minimums and maximums. And I just have to make sure I'm on the left side of the high point and the right side of the high point. Now, I've got 113, 104. Which value is the height? Well, the x coordinate is the time, the y coordinate is the height. So we're looking at the y value. So what is the maximum height? It is about 104. All right, so we use our maximum and minimum value on our calculator. And the last thing wants to know is how far did it go before it hit the ground, or where does it hit the ground? Or when? I guess it's when. Let me see. No, how far? Oh, actually, I'm telling you wrong. This is not time. This is linear distance and height. Sorry about that. Linear distance and height. So at 0 feet, that's still 0 right there, or right here. That's still 0 right here because the ball's traveled 0 feet. So the problem, this is actually length and this is height, not time. I'm thinking of something else. All right. But still the same, that's the height 104. The length, that means that 113 feet from where he kicked it is where it reaches its high point. Well, to find how far it goes, we need the x value of this right here. So that is where it crosses the x-axis. So if you remember second trace, 0. We haven't done this one yet. If we find the 0, zeros are where it crosses the x-axis. So if I want to find the 0, what I've got to do is I've got to pick a point before it gets to the x-axis, hit enter, and then pick a point after, and hit enter again. And obviously the height is now 0. It's sitting on the ground, but it went 228 or about 229 feet. Okay. So just a refresher on what we did. We put the equation in. We adjusted the graph so that would fit on there. This is the height of the football. This is the distance of the football from where he kicked it. All right. So if you could think of the little person standing right here and they kick the ball and it travels there. So to find out how high the ball is when he kicked it, we put in 0 for x, because that's the x is the distance from his foot, 0. To find out the high, we find the maximum. That tells us how far the maximum was and how high it was above the ground, which is 104. And then we find the 0 out here of when it hits, when y gets back to 0, that tells us how far away from it is. So there'll be a problem like that on your assignment. So that should be everything that is covered in this assignment. It's not that long of an assignment. There's, I think, 16 questions. So I'm going to go ahead and assign that, and let me go ahead and shut down the recording.